All right, so we are going to look at a problem in rotational energy. And it's pretty straightforward. What is the kinetic energy of a globe rotating slowly about its axis at a rate of 10 rotations per minute? Now we're going to assume the globe is a hollow sphere, so a thin spherical shell of mass 0.45 kilograms and diameter 0.6 meters. So let's just put that information down. We have a hollow sphere, and that has a mass of 0.45 kilograms, a diameter of 0.6 meters, which gives us a radius, of course, of 0.3 meters. Now, if we go and look up what the rotational inertia, the moment of inertia is for a hollow sphere, a thin spherical shell, we find that the I for a thin shell is equal to 2/3 the mass times the radius squared. All right, so we have the mass, we have the radius, we can determine the moment of inertia for that hollow sphere. Now, we want to determine what the kinetic energy is of this sphere rotating. So the rotation we found was 10 rotations per minute was what we were told. If I'm going to do energy, I need things into standard units, and that's radians per second. So let's just convert our 10 rotations per minute into radians per second. So in one rotation, I have 2 pi, whoops, wrong one. It's the other way. In one rotation, so they cancel, I have 2 pi radians. And in 1 minute, I have 60 seconds. So if we do our conversion from rotations per minute to radians per second, we end up with 1.05 radians per second. Now I can look at my kinetic energy relationship, which was 1/2 I omega squared. All right, so our I is 2/3 the mass times the radius squared times omega squared. And now I have all of the information I need. So 1/2 times 2/3, guess I could have shortened that a little bit, times the mass of 0.45 times the radius of 0.3 squared, times 1.05 quantity squared. And we find that our kinetic energy is 0.015 joules. So recognizing what the important features of kinetic energy are, recognizing the object we have, and that gives us an indication of the moment of inertia. Here we had a thin spherical shell. It was rotating about its axis, so that's an important element as well when we look up our rotational inertia equations. All right, good job.